Yeah. All right, so I'm Greg Rocco from MIT Lincoln Laboratory. I'm editor of OpenVPX. I was editor of VPX for the last revision that we did. And I'm a key contributor to SOSA and HOST. And I'm going to give you an update on OpenVPX, and then I'm also going to go through. So I'm going to start out by going through some slides from Jason Derner. We'll give a CMOS, SOSA, and HOST update that he put together for another conference. And then I'll talk some about OpenVPX and the associated standards, review. We'll go through what slot, backplane, and module profiles are, and how various standards are used to define the optical interface to the backplane, the relationship of OpenVPX to other standards works, and then I'll go through some of the trends with OpenVPX, where change is happening and where things kind of stabilized. All right, so here are Jason's slides. First thing he brings up is why MOSA? And there's 3 points of view here. There's the Army CMOS list to reduce size, weight, power, and so forth, a bunch of other things. There's a Navy host, and then there's the Air Force SOSA. And these things are not that different, and so you'd ask the question, well, why don't we all work together? And the answer is that we are working together. And so what SOSA is ending up being, to some extent, is a melting pot of the standards that the government needs, which are the ones over to the left. And then they're leveraging the industry initiatives or standards that are over to the right. Some of the latest additions to SOSA are Victory and More standards. So Victory and More used to be separate from SOSA, and they've recently been brought in. DEW's directed energy wave, directed energy weapon has come into SOSA also, and there's now we're starting to do a bunch of work in the space area. There's a committee that's been stood up for doing space work. There was some showing of layers in the presentations yesterday. Here's another view at layers for standards. If you look at the top of this chart, there's open standards that are done by industry. Over on the left, you've got VITA standards for the cards, plug-in modules that we do. There's some software standards in the middle. 46.11 is a system management standard. And then over on the right, we've got some of the SAE standards and some of the things that are used for chassis level connectors and things. So you start with those open standards, and then SOSA is taking a bunch of those and kind of cherry picking a subset. And so SOSA picks a subset of those and may add a few things that we're lacking. And then CMOS, the next level down, is picking essentially a subset of SOSA. And again, it may add a few things that aren't in SOSA, but in general, we're trying to have everything in SOSA that CMOS needs. And then there's the CMOS mounted form factor, is 3U-VPX, and it's picking a subset for the larger CMOS. So it's interesting to see how things neck down for a particular area. In this case, since Jason's with the Army, it's a CMFF, or the Army's point of view there. What's next for SOSA? And Snapshot 2, we've been done with it for a while, but it's still going through the publication process. It was supposed to come out at the end of December. I'm not sure exactly when it's come out, but it will be soon. And so here are some of the things that are in that. There's EOIR, wide area surveillance has been added. There's the NAV data services of Victory, security stuff, data model things, and as I mentioned earlier, More and Victory have been added. There's chassis connectors being added, changes happening there, additional mechanical interfaces. And then over on the right, there's Tier 3 IPMI has been added. And then some update to plug-in card profiles. One of the things here that, and you'll see this in OpenVPX also, is we've added video, the ability to have video over the backplane. And then there's small form factors. Small form factors is being aligned with Space VNX And one of the things that small form factors has added is amps when that gets published. There's also things going on with the real-time environment and SOSA data message definition. And then beyond that, we've started working on what will be snapshot 3. There's COM, sensor threads, encryptor, decryptor things, extension of EOIR, nav data service, tracker updates, security alignment. And as someone was commenting, a lot of these things are software. So SOSA obviously is standardizing a lot of software as well as the hardware. Looking in the middle here, there's security stuff for zero trust, more system management, data models being updated. And then over on the right, we've got hardware management card to help with the system management at the chassis level. Plug-in card profile, there's some changes there. And I'll point out that some of the terminology in SOSA is a little bit different from OpenVPX. So SOSA talks about plug-in module, plug-in card profiles. In OpenVPX, we'll talk about module profiles. So they're kind of the same thing. Small form factors, additions, and then there's some signals of opportunity at connector for Snoop, the chassis level, and real-time environment, virtual discretes, and just some general document cleanup. Let's see, on this I'll just point out in the lower right there, the updates for the OpenVPX form factor. We've included some payload pinouts. These are the blind mate coax. We're indicating what's transmit and what's receive. We've got the connection there, the coax for the Snoop input, video coax and fiber connections, and so forth. What's next for host? Host version 5 and 5.1 is released. We're working on in host to come up with a Cameo-based model, and that the standard will be derived from the model, and this will help with systems engineering. There's a paper that differentiates host and gives the differences between host and SOSA. And then we're developing a verification authority, and there's a common hardware integration layer, CHIL, standard in development. And here a bunch, when you get these slides online, here's pointers to various resources for SOSA, CMOS, and host that are available on the web. All right, so that's the end of Jason's slides. All right, so what I'm going to do next is go through some of the OpenVPX and its associated standards, sort of show you what OpenVPX is standardizing and how it does some of that. So I know I've shown this slide before. So OpenVPX is the interface, is specifying the interface between a plug-in module and the backplane. And then there are standards like VITA48 that are specifying the mechanical interfaces between the plug-in module and the chassis for cooling. And then we've also got the VITA66 and 67 standards that are standardizing the optical and coax connections to the backplane. OpenVPX profiles, there's some profile diagrams shown there, as well as pictures of backplane slots. Slot profiles specify the pins associated with the backplane slot, the pins associated with a plug-in module as backplane connector, and then those pins are assigned particular ports, like an Ethernet port. And then backplane profiles specify which slot profiles a particular backplane has where, how those slots are interconnected. And both backplane and slot profiles are protocol agnostic. The protocols are layered on by module profiles. So module profiles are specifying what protocols go over all the ports that the slot profile sets up. And we've got legacy type module profiles, and it was mentioned yesterday, the newer style is to use a string to specify all the protocols that are going to go on the ports. And so that's referred to as amps. In addition to specifying the protocols, it obviously specifies what slot profile some of the mechanical form factor aspects. And slot profiles have a dash option which says which optical and coax connectors are there. And part of the AMP string is to specify that dash option. These standards that are documenting the optical and coax are shown here. Over on the left, we've got the thing standardized by VITA 67.3. That's the RF contact interface, the RF connector module, the guide features, the backplane aperture, which is the hole in the backplane where the connector module is going to go in, and then backplane connector module dimensions. Over on the right side, we've got VITA 66.5, which is now the most common optical interface standard that we've got. The secondary guide features are specified by that. And then these guide features are used also, not just optical, but then we've got hybrid optical and coax hybrid modules shown there in the center. And then the MT ferrule interface is specified by 66.5. And the primary guide features for optical and hybrid connector modules. And then in 65.1, which is really it's the OpenVPX standard that has all the tables in it, it specifies the X and Y locations for the RF contacts, the MT ferrules, the guide features within a backplane connector module. And just a little bit more on these standards. VITA 65.0 is defining, the slot profile in 65.0 is defining the hole on the backplane where the connector modules are going to go, or the spot in the plug-in module where the connector modules will go. And then the dash options, which are in 65.1, will specify which connector modules are part of the slot profile. All right, next I'll talk about the relationship of OpenVPX to other standardization efforts. For what goes into OpenVPX, we're continuing to get input from the VITA member companies. We get input from the SOSA hardware working group, the host community, both those working on it and the end users of host, and then the Army C5 ISR Center, CMOS. We get input through, really through SOSA. The community, they influence SOSA. Also taking input from VITA, we're taking input from VITA 65 back to SOSA, and there's several of us that are working both on SOSA and VITA standards, so information can flow in both directions. In SOSA, we can have discussions which are ITAR controlled or export controlled to come up with the best solution in relation to target applications, whereas in VITA we can't talk about details of the application that are export controlled. So that it helps us to be able to have those discussions and come to agreement as to what some of the requirements are in the SOSA side. And then we're working to align SOSA, host, and CMOS and OpenVPX, trying to get things as aligned as we can. All right, so now we'll go over some of the trends in OpenVPX. I'll go first over the connector modules for optical and coax connections in the backplane, and then some of the trends with slot profiles. One of the main trends there is you'll see some of these have peaked, like the slot profiles peaked in 2019, and we didn't add any in 2023, and we don't expect any in the next round either. Whereas protocol sections, we've kept adding protocol sections. And so we'll see some of those trends. The latest version that's published came out in June of 2023 of both 65.0 and 65.1. Some of the things that were added in the 2023 version, we added 2 connector modules to 65.1 in addition to the 26 that were there. These were added in order to support 75 ohm video connections over the backplane. And then we've added Ethernet, general purpose, electrical, analog video, and digital video protocols. So those are the protocols that go over the 75 ohm coax connections that we've added. And then no slot profile or backplane profiles were added in 2023. In 2019, there were 5 new 6U and 6 new 3U. So there are a bunch in 2019. And then in 2021, there was just one new 6U and no new 3U slot profile. So you can see that we have not been adding many slot profiles since 2019. And then, as I said, we've added support for video. So there's been 2 connector modules that were added in the 2023 version that have 75 ohm contacts. And then we've added some slot profile dash options that specify to use those new connector modules. And then we've added several video protocol sections. Work in progress for what's expected to come out late 2024 or sometime in 2025. In our current draft, we've added DisplayPort 1.4. This DisplayPort's already in Vita, but we've added 1.4. There are currently no new backplane or new slot or backplane profiles, although there are slot profile dash options. Their dash options, as I said, are in 65.1 and specify which connector modules go in the holes in the backplane. Dash options also specify optical profiles. So these are how the fibers in an MT are mapped into pipes and how they're used. And then regardless of the slot profile dash option, the aperture, the slot profile hole, the hole in the backplane stays the same regardless of the dash option. Optical profiles are being added to support single mode optical fiber. And then we're working out next generation connectors. So I'll page through these. This is what was in the 2017 version, added these 5 connector modules. You notice one of the trends here is the density. You can see, in the lower right there, the density, we've got 12 coax connections. And then in 1 MT on each of these, it's most we have here in TEBs. And then in 2019, we added another 5, and here we're starting to get use Vita 66.5, and we're getting higher density. You can see many of these have 2 MTs. We've got in the upper right there, we've got 2 MTs with a bunch of coax contacts. And then in 2021, we've got a bunch were added. A bunch more density in the coax and a bunch more density in the fiber. And you notice on the lower right there, we've got 6 MTs in the space of one of the backplane connectors. And each of those MTs can take 24 fibers. All right, and here's some more of these are smaller width connectors. And then these are the widest width connectors. And in 2023, again, all we did was add 75 ohm coax for video. And then here are the slot profiles in the 2019 version for 6U. And this is what was added in 2019 for 3U. And then in 2021, all we added was 1 6U slot profile, which is actually related to some of the other 6U slot profiles, and then added 2 backplane profiles. So the rate of adding for slot profiles is down greatly. Although now with protocols, these are the protocols that get mapped. The module profiles are now amps we'll use to assign to the various ports. These have kept going. In 2019, we've got Ethernet protocols were added. There was another one speed on InfiniBand was added. Yeah, actually, what's being added here is mostly the 25 or 26 gigabaud Ethernet. And then we added USB in 2019. This was part of getting rid of the user-defined pins that was mentioned earlier. We wanted to be able to specify what more of the SBC, single board computer stuff. So we've got USB, general purpose serial ports, and then there's also signals over coax and general purpose electrical were all added in 2019. And then in 2021, we added some more of the higher speed Ethernet. In this case, it's Ethernet just over 2 lanes. We added some more Aurora. We added more general purpose serial and more general purpose electrical. And in 2023, we've added some of the PAM4 Ethernet signaling. It remains to be seen whether the current connectors can handle this. My suspicion is this is really for the next generation connectors. One of the connectors that can use this is the VDA91 connectors. And then we've added a serial FPDP and more general purpose electrical sections. And then, as I mentioned, we've added video. There's a whole bunch of video protocol sections have been added with the 2023 version. In summary, the VITA, SOSA, HOST, and CMOS communities are giving input for revisions to OpenVPX standards. We've got 2023 versions are out. We've added 2 connector modules for 75 ohm video, more protocol sections for both analog and digital video. No new slot or backplane profiles were added. With the next version, we expect we're adding optical support for single mode fiber and some slot profile dash options to take advantage of those. Starting in 2023, the activity adding optical and coax has decreased, though we still keep adding, we've kept adding protocols. Since 2019, only 1 new slot profile and 2 new backplane profiles have been added. And 2023 had none. And that is it. Any questions?